So grab the paper that I put in the middle of your table and grab one of each highlighter color, please. Let me give you a second to do. We're again, for the sake of like speed, and I'm gonna go ahead and tell you like the reason. Oh, I didn't get them to your table either. Man, I suck. Sorry. I will go ahead and tell you that like my anxiety is definitely getting the most of me because, you know, like just in case we end up not being here. So I'm teaching this faster than we would ever do it under normal circumstances. And I recognize that, y'all. So if you need to tell me like, hey, I need you to say that again. I need you to go slower. I'm just not sure exactly. Like, please do that, okay? So first thing, with your pencil, right at the top of that paper, what sticks out to you from that song? What was clearly the message they were trying to send? Y equals mx plus b, right? So everybody write that across the top of your paper. So this, friends, is the equation that will always give you a line if you graph it. And it's called slope-intercept form. And the reason it's called slope-intercept form is because it gives you two important pieces of information about the line. Now, the reason that I use that particular song, because yes, it is annoying. I totally get that. It does stick in your brain. And I really appreciate, actually, the very off-key mx plus b, because the b is important. Take your orange highlighter and highlight that letter B in your equation. And that B, this isn't what oh, do you need a pencil, honey? That letter B doesn't actually stand for this. It stands for like a Greek word that frankly as a math teacher I should know and I don't remember. But I prefer to think of it as starting with where you would be, oh, that's an ugly E, where you would begin. Let me try to make that smaller so it actually fits. When you graph an equation in slope-intercept form, you are going to begin with the number that is at the end, that B. So if we look at so the actual mathematical term for this, I'm just not gonna get this the way I want it. I need to stop being so extra. There we go. I'll write it out to this side. That way. That's where that's still ugly, but you get it. So this is where you're gonna begin. Now the actual term for this is that it's called the y-intercept. We got some football players in here. When you have an interception, what are you doing in interception? When you intercept, what are you doing? You're like getting in the way of the other team's ball, right? Like you're like intercepting it? Interception, exactly. So a y-intercept is where does the line get in the way of the y-axis? So you know the y-axis is that one right there, right? So looking at example number 1, there's my B. That's where I'm going to begin. B. Okay, and so we're going to look at the y-axis and see how that says +1. That means the very first coordinate, our y-intercept is what it's called, where it hits the y-axis, is going to be right there at +1 on the y-axis. So you guys, everybody needs to put a dot, please, at +1. This is where you're going to begin always. Well, I guess I shouldn't say always, but 99% of the time. So you're going to put a dot at the +1, and that is where it's going to begin. So everybody needs a dot. I personally would definitely color code it because I think that's going to make it easier for you to refer back to. Because like I said, this is the most important thing, aside from solving an equation, that we're going to do all year. Now the M in the equation is the letter that we use to represent the slope. There's a reason we reviewed slope a minute ago to make sure that that kind of rang a bell to you. Now, the letter M actually stands for some like Greek letter that means climb. Sort of like when you climb a mountain, depending on the slope, it makes it easier or harder. So looking at number 1, take an educated guess. What number is going to tell you the slope? -2. That -2, exactly. So if I were you, I would highlight and put it in the same color so it makes it easier to refer back to. So my slope is -2. And we're going to use that slope to figure out where to put, because that's nowhere close to a line. So far all we have is a dot. So we're going to use that slope to figure out where to put the other coordinates so that we can get ourselves a line. But we just reviewed in our, a few minutes ago, you need 2 numbers in order to make a slope. You need a rise and you need a run. You need to know whether it's going up, down. You need to know how much it's going left to right. Anybody got an idea about what we would do? Because we got to turn that -2 into something that's got 2 numbers instead of 1. Anybody got an idea how I could turn that -2 into a fraction so that we could actually use it for a slope? And if you don't remember, that's okay. Coach Morton, again, that I co-teach with, he came up with an expression a couple years ago that I've been stealing ever since because it's a good one. He says, you need a number, I've got 1 for you. How do you turn that into a fraction? You just stick a 1 underneath it. We need a number because we need 2 numbers. We need a rise and a run. You need a number, I got 1 for you. So -2 is the same thing as -2/1. What I don't, this is a very common mistake that I see a lot of kids make, which is why I'm writing it in red. A lot of kids will just stick the same number underneath it. But -2 divided by -2, anytime you divide anything by itself, you just get a 1, right? So it can't be -2 over -2 because then you've just changed the value of it. So it's going to be -2 over 1. So now we have a rise and we have a run. So I'm going to take another color, which I recommend that you do too, and I'm going to circle that. That's going to be my rise. And this, I'm just using some of the highlighter colors you guys have. Excuse me. That is going to be my run. And I'm going to draw a slope triangle that's going to help me figure out where to put my next coordinates. So what do we think of when we think of negative? Do we think of going up or going down? Yeah. We think of going down, right? So that means, from the beginning point, from that little yellow, or not yellow, orange dot you've got right there, you're going to put your next coordinate 2 units down because that's a -2. So we're going to go down 2 because that's negative. And whenever we read a graph, remember I said you read it the same direction that a graph moves, this direction. So our rise, we're going to go down 2, and our run is going to be over 1. So that means your next coordinate, your next dot, to make that line is going to be down 2 over 1. It's important to note, these lines right here, those aren't actually part of the graph. Those are just there as a visual to help you figure out where to put your next ones. If you're like me and sometimes having too much on the page is a little bit distracting, some kids, and I want you to have at least 1 copy of this for your notes, like one example where it's counted out, but some kids just prefer to kind of use their pencil to count down and over. They don't like drawing a whole rectangle there. Doesn't matter to me. Whatever you want to do. Now, every math teacher in America, particularly the ones here at Ballard, are going to tell you that you need 3 coordinates in order to make a line. And because you can't really know for sure how straight it's going to be until you have 3 coordinates to line it up. So that means you're going to do that exact same rise, which is down 2 and over 1. You're going to do it twice so that you have a total of 3 coordinates. So I started at my beginning point. My y-intercept, my positive 1. Then I use the slope, which is rise over run, to figure out where my next 2 coordinates are going to go. Now, did I put those rulers in front of you on the table to look pretty or for you to hit each other with or anything like that? No. What do you think I put them there for? Draw a straight line. So, now, and I don't want this either, folks. I see a lot of this when I was in middle school. We're not doing that. That's not a line. That's a piece of a line. That's a line segment, but that's not actually a line. We want our line to go nice and long all the way across the graph like that. So use your ruler to connect those coordinates and draw them. Will you pass a couple? Thank you. And the protractor's right there too. So Adonis has one. Thank you. So draw your line going all the way across the graph. For reasons that'll be important in about 6 weeks, honestly, it's really not that super important right now, but it really will matter later, so it's a good habit to get into. You're going to get the wrong answer, like it won't work out right, if you don't make your line go all the way across. The other issue is that technically speaking, this line goes in both directions forever and ever and ever. So another thing we need to do to make it mathematically correct is we need to add arrows. So that, friends, is how we would graph any equation in slope-intercept form. You just start with the y-intercept. You start with the b, the beginning point. Then you use the slope to figure out how steep it is and where you're going to put the other 2 coordinates that you need in order to graph it. So that is way faster than we would typically do it. We're going to use the same procedure. There's something a little bit tricky about this one, though. What's not tricky, though, is that you're still going to start with the B, okay? So on the y-axis, so remember this one is the y-axis, the one that goes up and down. This is your y-axis. And we're going to put our B, our beginning point, on that y-axis. And what number are we going to place it on the y-axis? What number is our B in this equation? 4, right. And is it a positive 4 or a negative 4? Positive. It's a plus 4, exactly. So everybody needs a dot right there at plus 4. Now, unfortunately for us, the slope is going to be a little bit tricky. Okay, so we already know from the previous example that the slope is that number in front of the x. So I'm going to bring it down over here to the side so that I have a little something to work with. And what number is my rise? What number tells me how much I'm going up or down? 9, right? Here's the one problem that we have with this particular paper. Now, back when I was in your shoes, sitting in high school algebra back in the dark ages, they used to just give us graph paper, and we had to make every single one of our own, like, X and Y axes. It was a lot. It was really doing the most. And then we could just, like, go in any direction we wanted because you had a full sheet of graph paper. Because that is a positive 9, what direction do you think you're going to go up? Oh, darn it, I hate it when I do that. So I just gave away the answer. So because that's a positive 9, you would think that you're going to go up 9, right? What's the problem with the graph I gave you, though? Yeah, it doesn't go up far enough for you to have 9. Now, so that's kind of the trade-off. You don't have to draw your own coordinate grids anymore. We give it to you on paper. But the bad side of it is that sometimes you don't have enough room to do that rise. So you don't have any choice. You're going to have to, you still got to go up or down. So instead of going up 9, you're going to have to go down 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So your slope triangle will go down 9. But that's okay. It's fixable. Because Is down, is that positive or negative? Negative, right? And then, so don't do what I'm doing. That's why I'm putting it in red here. So I'm thinking to myself, hey, well, we read a graph going in that direction. So that's 1, 2, 3, 4 to the right. And what direction is going to the right? Is that positive or negative? That's positive. What's a negative and a positive when you have integers? Does a negative and a positive turn, two negatives make a positive? What's a negative and a positive? That's a negative. So if you graph it like that, you're gonna get it wrong because you went down, which is negative, and you went to the right, which is a positive. Just like two negatives make a positive with numbers, it also makes a positive with direction. So instead of going to the right, you're gonna go to the left because two negatives make a positive. So instead of going to the right, if you have no choice but to go down because you don't have enough room on the graph, you're going to have to go in a negative direction twice because we know that a negative and a negative is going to make our slope positive when we do that. So I'm getting ready to do the opposite of what I told you to do. Remember when I said you always do 3 coordinates? But I just didn't give you enough room on the graph to do 3 coordinates. So you obviously can't do 3. So go ahead and just grab that ruler and connect what you got. Don't give me any puny lines. Make it go all the way across the graph. And add arrows to it. And bam. You've just graphed yourself a line. Again, I feel like I want to make sure I point out to you because sometimes kids get confused, and I know last year was a dumpster fire, so in 8th grade, a lot of you guys didn't get a chance to do this. That slope triangle is not actually part of the graph. It's just there to kind of give you a visual. Technically, this is what we're going for right there is just that line. But you don't need to go back and like erase your slope triangle or anything. You don't need to do that. But just want to make sure I point out to you the line is actually your answer. So I'm going to shut up for just a second. Give you a chance to look at number 3. mx plus b. Figure out where you think your b, your beginning point, the very first thing that you're going to graph. I cannot stress enough how important pencils are for now because, to be honest, you're probably going to make some mistakes. It's part of the process. There's a lot of places you can accidentally go wrong. Be a good idea. So I want everybody to take their best educated guess based on those 2 examples. Where is your first dot going to be? Oh, I see so many people got it in the right spot. That's awesome. mx plus b. So our b, our beginning point, is going to be right there on the y-axis at positive 4, because that's what our y-intercept was. And now we need to use that slope, the m, in order to figure out what direction it's going to move in so that we can figure out where our other 2 coordinates are going to go. Do I have a rise and a run the way that's written right now? So you need a number? I got 1 for you. I need 2 numbers. What direction? That's a -6. Does that mean up or down for a rise? That means down. Do I have room to go down 6 this time? Yeah. Yes, I do. So 1, 2, 3, 4, 5, 6. And when we say over 1, make sure you're careful about what direction you do that in, because what I see kids do a lot is say, oh, well, it's a negative slope. That means I need to go in a negative direction. But what happens when you do a negative and then you go in the negative direction twice? You get a positive. So you don't want to do that. You don't want to go to the left. You want to go to the right. because that will make your positive. So your second coordinate is gonna go right there. Once again, I've given you a graph that doesn't have enough room for you to do 3 coordinates, so you're only gonna be able to do 2. So take those rulers. Bum, ba-da-da. And give me a nice long line. I need to make mine a little bit bigger. That's a skinny. That's really skinny. I don't remember how to do that. Oh well, can you guys see that okay? I realize my line is super skinny. I gotta remember, I haven't used this for weeks. I forgot how to make that line bigger. Okay, so now that we got those 3 examples, I'm gonna shut up. I'm gonna give you some time to graph those yourselves. But I am obviously here to spot. I lied because this one does have a little bit of a trick to it too, because I see a couple of you guys getting stuck about. It's basically the opposite of number 2. It's got the same problem, but for a different reason. So let me zoom in here. First of all, mx plus b. Where am I going?
5.
I'm going to -5 on the y-axis. So we're going to start here, and then the slope is going to be that number right there in front of the x. So remember, it's always rise over run. Now, because that's a -10, that makes you think you should go what direction? Down, but do we have room to go down? No. That's why these the concept itself really isn't too terrible. There's a lot of places to mess up. You don't have a choice but to go up 10 because you don't have room on the paper. So I'm going to go ahead and go up 10 instead of down 10. And because I went up, and that's positive. If I go to the right, what direction is the right? Positive. That's positive. Does a positive and a positive make a negative slope like we need it to be? It does not. So that's where you need to be careful. Since we had to go up, you've got to make sure that you go in the negative direction. So we're going to go to the left 3. And that's where your second coordinate is going to go. And then when you add your line, it's going to look a little something like that. And Coach Morton's I like Coach Morton's it's always a good idea to go back and check and make sure it makes sense. If you draw your little man, your little guy that's like, so remember, this is your start, right? Is that guy getting ready to climb a mountain, or is he getting ready to go slide down a slide? So he's at the top, yeah, so he's getting ready to go down. So that's the correct negative slope that you needed, okay? So that is, all we're going to cover tomorrow is just going to be, but practice, practice, practice while you're working on that.